Hello everyone and welcome. First of all, thank you very much for joining us on this online reInvent edition. My name is Adrian Hornsby. I'm a Principal Developer Advocate with AWS, focusing on architecture. And today I want to talk to you about immutable infrastructure, which is a model where no updates, security patches, or configuration changes happen in place in production. As the title of the presentation suggests, immutable infrastructures are more reliable, consistent, and predictable, and they actually simplify many aspects of software development and operations. So let's dive in. So what is immutable? So as per the dictionary says, something that is immutable is something that is not capable or susceptible to change. All right, but why does that matter for us? Well, before answering that question, let's take a look at how traditional infrastructure work, because the problem of mutability in traditional infrastructure is probably more familiar to you. So not so long ago, it was quite common for folks to brag about uptime. And you can see on many forums, people still post photos about their computers that have been up for 16 or even 25 years. So the problem though with uptime, and especially for long uptime, is that it often indicates potentially lethal problems because there are critical updates, and critical updates, software and hardware ones, often require rebooting. So let me ask you one simple question. Which of these two choices makes you more anxious? First, rebooting a 16-year-old server or rebooting a server that's just been launched? Well, that's right, probably the number two. Well, because for me, just the idea of thinking of rebooting a 16-year-old server makes me very nervous, because I have no idea what's changed in the 16 years since the initial boot up. How many undocumented hotfixes were done? Why was it never rebooted in the first place? Are there some hidden dependencies that we don't know about? Or some magic switch? For me, that's terrifying. Also, in traditional infrastructure, servers are typically updated and modified in place. We love our SSH. We SSH into our servers, we install, we update, we upgrade packages. It goes something like this. You log in, you stop the app, you update the repository, you do an upgrade, you test, sometimes debug really often, and then try to restart the app. And then often you want to hope for the best because very often the system doesn't restart as expected. So all these were, and actually often still are, quite standard practices. Less common practice though is really documenting all those changes. And in the update process, it's often a downtime period. So interestingly, the processes like change management or ITIL that have been created by the industry to try to solve the problem of changes really never address the problem in the first place, but instead they slow things down. In my opinion, the solution to mutability is not processes. It's not having changes in the first place. And with the cloud, it's becoming more and more easy. And actually, even more advanced architectures can have problems. I've seen really well-architected architecture where people still SSH into the boxes. Really, I call that the SSH love syndrome. We say often like, okay, no, just the last quick edit on Friday, a quick edit before the weekend. And then we kind of make promises like, I will document everything on Monday, I really promise. And actually we never do. And then over the weeks, things start to really get crazy because we, pile the changes that were undocumented, and this is really becoming a configuration drift. So one of the main challenges with configuration drift is that they make it really hard to do any updates anymore because things have changed, and it's really hard to debug as well because often the documentation doesn't represent what is in production. And it also makes recovery very, very difficult. So Another common practice in traditional infrastructures is what we call mutable deployment pipelines, meaning that the deployment pipeline gets the code, fetches the dependency, builds the artifact, deploys them for every environment stage of the deployment pipeline, whether it's beta, staging, production. Everyone gets a different build, one build per environment. What you test and validate for each of the stage is not what you deploy. I've seen places where deploying to production means starting any instances and having a script to install things. Like you fetch the code from different repos, you build it, you replace artifact in place, and then you reboot. One step is missing though in this is really pray. I'm sure that behind the screen you all are either smiling or horrified by the idea, but really try to think about the following. How many of your application fetches dependency from the internet during a build process, or worse, at runtime? How about pip or npm install? How about Docker build? Well, what guarantees do you have that the dependencies you are installing don't change between the deployments? And what if you are deploying to multiple machines or environment? If you don't believe me, I encourage you to read those articles, which is how one programmer broke the internet by just deleting a tiny piece of code from his Git repository. So what happens if your code repository has issue when you deploy? What happens if it's not available? Well, installing dependency at runtime is also an attack vector for malicious code injection. And actually it renders scaling slow because you have to download the dependencies before scaling. So that deployment behavior is really fragile at best and often leads to big mistakes and actually very frequent rollbacks. And that's if you're lucky. So luckily there's a solution, and you probably have guessed, is immutable infrastructures. So put simply, immutable infrastructures is really a model where no updates, no security patches, no configuration change happen in place on the production environment. If change is needed, what we do is we deploy a new version of that architecture and we deploy it in production. The most common implementation of that pattern is called the immutable server. So that means that if we need to deploy a new version of that server, we actually deploy a new version of the golden AMI. We then update the libraries offline, we do the tests, and then once we are ready with all the tests, we simply update the routing. And that update process is without any downtime. That pattern for immutable servers also apply for containers and for serverless function, and we'll look at that very soon. So instead of logging via SSH to the server and updating the different software versions that you need for your application, when we do an immutable deployment, the immutable deployment starts with what we call a git push, so a software push to the code repository. And since changes are not allowed, you can be sure of the state that is deployed. And that pipeline is exactly the same for beta, staging, and production. That means that you have one build for all your environment. And it's not a new idea, actually. The term immutable infrastructure was coined by Chad Foley in his blog from 2013. And this idea has really gained popularity, and rightly so, because it helps simplify the deployment process, and it actually, especially in more complex and distributed environments that we live in now. So there are multiple benefits to immutable infrastructure. The first one is that by frequently replacing your server, to a known and a version controlled configuration, you kind of reset your infrastructure to a known state. So you avoid and you limit configuration drifts. Second, the deployment are really simplified because you don't need to support upgrade scenarios. Upgrades are just simply new deployments. Third, the deployments either complete successfully or nothing changes. So it makes the deployment process really reliable and trustworthy. There's no in-between states. They are also safer because the previous version of your software and working version of that software is not changed. It's just put on the side. So you can roll back almost immediately if errors are detected. And since all the servers are running a particular version of the application, the same image, there are no difference between the environment. It's very consistent. And then since servers use the same image, they are consistent and repeatable. So it makes auto-scaling really trivial to implement. And it's actually significantly increased your capacity to scale on demand. The toolchain is simplified because you get rid of all the configuration management to support different versions of upgrades and things like this. And finally, but really very important, is by denying all the changes to your server and by disabling SSH and removing shell access to the server, you reduce the attack vectors for bad actors and in turn improve your security posture. So to hit the nail on the security part, I'd like to state that mutability is actually one of the most critical attack vectors for cybercrime. When a bad actor attacks a host, what he wants to do is modify servers in some way. For example, you change the configuration, you change files, you open different network ports, you replace binary, you modify them, you inject new code. All these are changes, right? So when you detect such an attack, right, that pretty is essential, but preventing them is way more important. So in a mutable system, how do you guarantee that the changes that are performed on the servers are actually legitimate or not? So once the bad actor has the correct credential, you just can't know. So the best strategy to avoid such a thing is simply to have immutability in place and deny all changes to the servers. So if a server is compromised, then it should be either stopped, quarantined, terminated immediately. And that's what DevSecOps at its best is detect, nuke, and replace. So deploying application in immutable infrastructure should try to use what we call the canary deployment pattern, which is a technique that reduces the risk of failures when new versions of applications enter production. By instead of replacing in place, it creates a new environment with the latest version of that software. And then you gradually roll up the changes to a small subset of users and slowly making it available to everyone if no errors are detected. So it's also sometimes called a phased or incremental rollout deployment. So once the new version is deployed to all your users, you can slowly decommission the old version. But of course, you have to keep it a little bit, a few days on the side in case things can go wrong, because sometimes you can detect errors after a few days or hours or days. So this strategy really minimizes the potential blast radius of failures and limit the impact on the customer. And it's therefore really recommended. So the benefit of this kind of deployment is, of course, as I mentioned, the near rollback capability it gives you. But more importantly, it's fast and safer deployment where you actually can test with real production data. So the main challenge with canary deployment is the routing strategies. A lot of the time, customers have asked, how can I route? What is the routing strategy that I should use? Well, there are several that you can consider. First is internal versus external customers, right? Internal team with your customers and things like this. Then if you have a free tier, you can have a deployment strategy between paying customers and non-paying customers. You can have geocentric type of policies, routing policies. Of course, you can also use feature flag. This is probably the most common one. And then also random. So how do you do canary deployments on AWS? So there are a few ways, and these are some of my favorite. First is using Route 53, then using auto-scaling groups, using load balancers target group, using API gateway release deployment, and of course AWS Lambda alias traffic shifting, which is quite difficult to pronounce. But we'll do a demo on the last one. So to the first one, Route 53 lets you use what we call the weighted routing policies, which splits traffic between the node and the new version of the software that you're deploying. So this is really probably the easiest one because you do the change on the DNS level and then just simply redeploy two versions of the architectures. Now it's also probably the most costly one because you have two versions of your architecture running at the same time. So when weighted routing enables you to associate multiple resources with a single domain name or a subdomain. And that subdomain is actually quite interesting. Then you can do quite interesting sharding and split traffic based on that subdomain. So to configure the weighted routing for Route 53, you assign each record a relative weight that corresponds to how much traffic you want to send to each resource. And then it will send traffic to the resource based on the weight that you assign to the record as a proportion of the total. So, for example, if you want to send 10% and 90%, you will want to have 10 and 90. Right? That's quite straightforward. So there's probably one issue though with Route 53, and it's DNS propagation. So while it takes approximately 60 seconds for Amazon Route 53 to update its worldwide network of authoritative DNS servers, the caching servers, right? So the rest that are not managed by Amazon are really outside of our control. Sorry. And they will cache your resources based on the TTL that you set for your record. So my advice is really watch out for those TTL values, right? And try to minimize them, especially if you are doing these kind of things. So 60 seconds, 90 seconds, maybe 300 seconds maximum for these kind of things. The second strategy is using auto-scaling group, right? And this is what I call the old school method because it's one I've used in production for many years in the past. So the basic pattern, you need two auto-scaling groups, one which has maybe 3 instances and one that has 1. In that case, you have 25% of the traffic that goes to the smaller auto-scaling group with 1 instance as opposed to the other ones. So then you can slowly increase the number of instances in the second auto-scaling group and then slowly reduce the numbers of instances in the first auto-scaling group. So you can do a progressive rollout as well. Of course, the number of the instances define the kind of the grade or the number of the percentage at which you can switch traffic. So the more instances, the lower your increase. So be careful with that. You can automate that method using CloudFormation because it supports update policy, which is an attribute for auto-scaling rolling updates. So the third method is using the application load balancer and weighted target groups. So when you create an ALB, you create one or more listeners, and then you can configure the listener rule to direct traffic to one of the target group. And the target group tells the load balancer where to direct the traffic, whether it's an EC2 instance, a Lambda function, a container. And to do the canary deployment with an ALB, you use what we call the forward action, and then you can route the request to one or more target group. And then you just simply add the weight for each of your target group. So, for example, again, in this view, we'll have 10% and 90% here. You can also actually enable stickiness, so that stickiness is if you want to each request to hit the same server one after another. So you can also enable that even though you are using canary deployment. What will happen is once you enable stickiness, the load balancer will give you a cookie that will have the ID of the server that the session has been stick to, and then you can reuse that cookie for the subsequent request, and the ALB reroute the traffic to those instances. Fourth, you can use, as I said, the API gateway, release deployment, and that's quite easy. Basically, what you do is you set percentage of API requests that are handled by a new API deployment for a particular stage. And then you can use, of course, the CloudWatch metric to monitor the performance and the different errors of the API and then react to them. You can also gradually increase the percentage of requests handled by the new API deployment and rollback if errors are detected. It's worth noting, though, that the API Gateway Canary deployment only works for the REST API, so the first version of API Gateway, and not for the HTTP APIs. And finally, you can use AWS Lambda alias traffic shifting. And what you do is you simply update the version weight of a particular alias, and then the traffic will be routed to a new version of that function based on the specific weight. Again, you can use CloudWatch metric to monitor for the health and the different errors, and then roll back if necessary. Now, the interesting thing is you can, of course, and for every version of those canary patterns, you should really try to automate. And Code Deploy can help you do that. And I'll demo how to use Code Deploy to automate canary deployment for AWS Lambda alias traffic shifting. It's very hard to pronounce. So let's do the demo. And by the way, before I do the demo, you can get the code from my GitHub repository here. Yeah, it has a lot more, but basically the whole demo is available there. So we'll use the SAM application model, the SAM, what we call SAM template, to deploy the course, the code, and you'll see how it integrates with Code Deploy. So this is the function that we will modify. It's an echo function deployed in Lambda that returns hello world. So we can test it. This is returning hello world. We're good. So it's a SAM template that we use to deploy. The interesting part of the SAM template is, of course, the parameters, all the different resources that we can add, but particularly for our use case, the canary deployment, we want to see the deployment preferences that are assigned to the echo function. So here we have a linear 10% every minute deployment strategies. There are several that you can use. And the second interesting thing is the pre-hook. A pre-hook is a function that launches before we give production traffic to the function to verify that it works. So here the Lambda function as a pre-hook verifies that the new version of the Lambda function returns to 100. And then it updates Code Deploy with the lifecycle policies so that we can then send it production traffic. You can, of course, and you should, add alarms in case of errors so that we roll back. So let's change the templates. Let's deploy hello worlds. And for that, we're going to build first using SAM build. So we are building the different functions and the different package that needs to be deployed. And once we are built, we can do a SAM deploy with the different parameters that we need. And when it does that, it reuses CloudFormation under the hood and will give you the different change sets that you can accept or not. And then it will start the deployment processes, right? And you'll see it will give you the ID of the deployment process for Code Deploy once it's available. And here we already have our updates in progress with that ID. So then we can go into the developer console for a Code Deploy and look at the deployments. So as you can see, my deployment is in progress. And that's really good for us. The pre-hook has already been succeeded, so that means the function, the new version is returning to 100. We can look at the revision details that give us detail on what is being changed. Here is really our echo function that is being updating. And then we already have 10% of the traffic to the new version. So let's try it, because that means maybe 1 out of 9 or 1 out of 10 hit on the function should return probably hello world. So let's try a few times to see if we can get an hello worlds. All right, and yeah, we can. So we are getting some hello worlds already. And as you can see, also, we are now sending 20% of the traffic. Now, of course, if there are errors, we want to stop. So here we can test the stop and rollback. And as you can see, it immediately stops everything and rolls back to the previous states, which is the hello world function. It also sends signals to CloudFormation that also updates your deployment status. So that's pretty much it for my demo. What I want to give you now is some resources. So you can, of course, go to the well-architected framework that will also give you more details into how to do your self-deployment. You can practice in the well-architected labs. You can go into the architecture center and, of course, look at the different libraries, the solutions library that we offer there. I've published a full version, blog version of that particular talk with all the examples, deep diving on every part on my blog on Medium at Horn. And you can also, of course, contact me on Twitter. So feel free to contact me. I'll be happy to discuss all these kind of things with you. And again, thank you so much for tuning in, and I hope to hear from you very soon. Thank you very much. Don't forget, though, before we leave, to complete the session survey. This is very important to give us some feedback so that we know how to improve next time. Again, thank you very much, and have a wonderful rest of reInvent.